Yeah, so we were talking about autonomy, but before that, let's think about the potential benefits that AGI could have for humanity. And then we could talk about limitations and what needs to be done on that side.
Yeah. So, you know, we humans are the inventors. That is kind of what sets us apart from the rest of the animals in the entire world is we build things that help us. We have telescopes that can see literally to the edge of the universe. We have microscopes that can see individual electrons. We have machines that can lift tens of thousands of pounds, sometimes hundreds of thousands of pounds. We have airplanes that can fly faster than the speed of sound. We build things that are better than us in every possible way. And so, what many people are, I'm not going to say whether or not they're ready, but some people seem like they're not as ready for the idea that we're building thinking machines that are better than us, that they can solve problems that we can't solve. They can think faster than us. And so, the way that I look at this is we're building a class of machines that has the ability to do mental labor or cognitive labor. Because up until this point, most of the machines that we build they either do sensing, like cameras and telescopes, or they do physical labor, moving stuff around. You have warehouse robots that move goods around a warehouse. You have trucks that move stuff. You have forklifts that pick things up. Those are kind of the two primary categories of automation that we have is whether it's sensing automation or physical automation. And then, of course, we have computer automation and digital automation. And AI is basically going to take all that to the next level where it's like, okay, if there's a task that only a human is capable of doing mentally, pretty soon we're going to have machines or computers that are capable of doing any task that a human is mentally capable of. And that unlocks a whole lot more potential in terms of what kind of industrial and technological innovation and automation we're capable of. So what does that translate to? You could automate lawyers, you could automate doctors, you could automate energy grid managers. There's all kinds of things you could automate. But the primary way that I think about it, at least in the near term, is that it is a new kind of automation. I think that's probably the best, most familiar way of thinking about what is it that AGI can do. And so when you can automate tasks, these things do it much cheaper. So for instance, I've talked to clients and other people. There was one client that I had that was able to replace a bioinformatics statistician with ChatGPT. So instead of having a human with a salary of $8,000 a month, they use ChatGPT that costs $20 a month. The difference in cost makes it super compelling. Even if it's not as good as a human, it is literally hundreds of times cheaper than a human. And so even if it's 50% as good, the cost difference makes it well worth it. And that is what we've always done with automation, right? That is why we moved from horses to tractors and from tractors to combines, is because yes, some of these machines are larger and more complex and more expensive, but the amount of work that they're able to do, the return on investment makes it incredibly compelling to use them. And that's what I predict is we're going to see is pretty much everything that you need done is going to be automatable very soon. Now, how that has impacts on the larger economy and our lifestyles, that remains to be seen, but we can certainly make some predictions about that as well.
Yeah. So what you're saying is that we could benefit a very cheap labor cost because the machines would be able to do lots of the tasks that humans are currently doing, and maybe more complex. Would you say it would be more complex tasks that maybe, if I understand only as a lawyer, only one side of the law, I could only understand that, and I'm not understanding, other parts of the law, and these machines could do like integrations of data between different topics or something like that.
Yeah, so there's a few ways in which the machines that we're building, that some of them are better in some ways already, and some not so much. But there's a few metrics that you can look at. So one is cost, as you mentioned. And another way to think about how technology can reduce cost, you can send an email to 1 million people around the entire world. Before the advent of email, and that's basically free. Before the advent of email, it would have cost you literally tens of thousands of dollars to send letters all over the world. So you go from something that costs tens of thousands to hundreds of thousands of dollars to practically free. So that's one thing, is things with technology get much, much cheaper over time. Another thing is it can happen faster. So the example that I gave earlier of using Claude to read a 100-page legal document in just a few seconds. No human is capable of reading that fast. It takes 20 to 30 seconds right now, and it's only getting faster too. So imagine not too long from now, you can have something that reads not just one document, but 10 documents every 10 seconds, and that can find the correct information that you need. So it can be cheaper, it can be faster. Now, in terms of complexity, this is what I call better. In some respects, machines are better than humans in that they can solve problems that humans can't or that they struggle with. So really, one of the most powerful examples of this right now is AlphaFold 2, which was built by Google DeepMind. So if you're not familiar with AlphaFold 2, what this does, it forms a mathematical model of proteins, and it is able to predict how proteins fold and misshape. And that might sound like, okay, that's just origami, but it can this database that they've been able to produce with AlphaFold 2, I think it already has over 200,000 proteins. And what this figures into is that it allows you to predict how proteins are going to behave, which means that you can predict which medicines are going to work or which ones are going to cause diseases. And that has greatly accelerated the process of drug discovery. Bless you, Gesundheit.
Thank you. It means that it's true.
Yep.
That's what we say in Hebrew.
Yes, it's very true what I'm trying to say. At least I believe it to be true. So, but yes, so better, faster, cheaper, and then the last criteria that I look at is safer. So the one thing is that if machines are famous for being very consistent, right? If you want something to churn out t-shirts 24/7, 365, you use a machine. You don't use a person to do that. Likewise, if you get someone away from dangerous machines or dangerous scenarios, you can also reduce risk to humans by just getting humans out of the loop. We do this with industrial automation, right? You get humans out of the workflow, out of the workshop. Yep. You get it out of the factory. And so you combine that consistency with getting humans out of the way, and you can end up with safer. And so those are the 4 criteria that I look for: is better, faster, cheaper, and safer. As machines get closer to those thresholds in any particular job or domain, we should expect the machines to replace humans. And then, of course, the machines hopefully will only continue to get better after that. And so if that's the case, then you're looking at what is called jobs dislocation or job destruction, where it no longer economically makes sense for a person to be doing that job ever again. And we've seen this plenty of times in the past where, we don't have telephone operators anymore. Why? Because machines can do it better, faster, cheaper, and safer than a human telephone operator can do. It's all automated.